the principal investigator for the GRAIL mission, Dr. Maria Zuber, and she is from MIT, the Massachusetts Institute of Technology. She's the head of her department there, the Earth, Atmospheric, and Planetary Sciences at MIT, as well as she holds the E.A. Griswold Professor of Geophysics. In addition, she's a consultant with the Aerospace Division at the MIT Lincoln Laboratory and a senior research scientist at the Laboratory for Terrestrial Physics at NASA's Goddard Space Flight Center. Her research interests include theoretical modeling of geophysical processes, analysis of altimetry, gravity and tectonics to determine the structure and the dynamics of the Earth and solid planets, and the development and implementation of spacecraft laser and radio tracking experiments. She's going to obviously talk to you about the science and then also the project as a whole. Dr. Zuber.
Thank you very much. I'm absolutely thrilled that you're all here, and I'm very pleased to talk to you today about the science and mission for GRAIL. Next slide. Okay. So we've been to the moon. Okay, we've 109 spacecraft have orbited the moon. 12 humans have walked on the moon. These 12 individuals who have walked on the moon have brought back 842 pounds of moon rocks that are still being analyzed today, 40 years after they've been brought home. They continue to be analyzed with new instrumentation. We continue to learn things from those samples about the moon. Why do we need to go back to the moon? Next slide, please. Okay, well, this is our idea of how the moon formed. Let's see, I think they told me this video wasn't working, so I have more time to explain it, and I'll probably go over it. We believe the moon formed from the impact of a Mars-sized body into the Earth at a strafing angle. The core of the impactor wraps itself around the core of the Earth, and the mantle of the impactor and the projectile get thrown off into a disk around the Earth, and the moon condensed out of that disk. Next slide, please. Okay. So this is an idea of what it may have looked like. Here's our Earth, and here's the circum-Earth disk that the moon condensed out of. Actually, it's possible, and I'll talk about this more, that more than one moon condensed, and this is one of the things that GRAIL will be looking at. Next slide, please. Okay, so if you look at the surface of the moon, on the left-hand side here is the near side of the moon that we see from Earth. On the right-hand side here is the far side of the moon that we never see unless we put a satellite on the back side. So what don't we know about the moon? So we've sent all these spacecraft to the moon. We've sent astronauts to the moon. We've left instrumentation on the surface of the moon. But we don't know why the near side of the moon looks different than the far side of the moon. So what's happened here on the near side is we have areas that are bright, that actually formed, we believe, when the whole exterior of the moon melted and very light elements floated themselves up to the surface. It's a mineral called plagioclase. Then, we believe, the moon cooled off, and large impactors, asteroids, hit the moon and formed depressions. And these depressions were filled with lava. And these are massive, giant lava flows, many kilometers deep. And these lava flows are the dark areas of the moon that you look at whenever you look at the moon. So these lava flows have formed because the interior of the moon melted in the past. Okay, so here's the near side of the moon, here's the far side of the moon, where you can see very little of this magma. And what we used to think is that, well, the inside of the moon on the near side melted, the inside of the moon on the far side melted, but the near side has all these impact basins, so the magma, when it was able to reach its way to the surface, whereas it just was never able to reach itself to the surface because the backside doesn't have big basins like this. If we go to the next slide, though, okay, here's an elevation map of the moon. Again, the near side and the far side. And this white and red represent high elevations, and blue and purple represent low elevations. So, just like what we said, the near side has these basins that are filled, but if you look at the far side actually has a basin that is bigger and deeper than any depression on the near side of the moon, yet it doesn't have filled with lava. So this tells us something. It tells us that the inside of the moon on the front side melted, but the back side apparently didn't. Okay? And so for all that we've studied the moon, clearly something's going on the inside of the moon that we don't know about or understand. Okay, so now I want to talk about the possibility that the Earth had a second moon. And the idea for that came from looking at this high material on the backside of the moon. This is called the lunar equatorial far-side highlands. And this material up here is high. And the idea is that as this disk around the Earth condensed, it formed two moons. One moon is our moon, and it formed another moon that was about a third of the size of our moon, that was in the same orbit of the moon around the Earth. And very slowly, this moon drifted close to our moon, and because it was in the same orbit, it hits it at a relatively low velocity, so much so that when it hits it, it sticks, and it adds more material than the moon to the moon than it excavates. And so instead of forming a crater, it forms a big mountain. Okay. Now, next, let's see. We'll see if the video works. So next slide. Okay. All right. No, it's not working. Okay, so that's it. Wait, you're going to bring it up here? Okay, so here's a simulation of that impact. Okay. So, yeah, this is a smooth particle hydrodynamic simulation of that. So you see nothing gets ejected because it just bumps it. And so this paper just came out actually about 3 weeks ago in the journal Nature. This is a brand new idea that we've never known about before. And the authors made specific predictions that can be tested with the GRAIL mission. Next slide, please. Okay, so the science objectives of the mission are to determine the structure of the interior of the moon from crust to core and to advance our understanding of how the moon evolved. And if you look at how heavily cratered the moon is, all the rocky planets looked like this at one point. 4 billion years ago, Mercury, Venus, Earth, Mars, all looked like this. On Earth, that record isn't preserved because there's been wind erosion, water erosion, subduction. But on the moon, this record is preserved very well. And because we're able to study the moon in great detail, what we learn about the moon can also tell us about this early formative